All right, we're finally at the definition of derivative. The derivative is one of the most important concepts in calculus. It's definitely one of the top two along with integrals, which we'll see toward the end of the semester. The definition of the derivative is given by this. The derivative of the function f at the number a is denoted by this symbol here. This is read as f prime of a. And it's given by this function here, and that tells us the slope of the tangent line, if provided that the limit exists. So it tells us the slope of the tangent line at the point with x coordinate a. You could also just think of that as the slope of the function, or the slope of the curve at that point, and it's also the instantaneous rate of change of f of x at that point. So whenever you hear derivative, those are the things you should think. Derivative tells you the slope, and derivative tells you the instantaneous rate of change. So let's do an example here. This first example tells us to find the equation of the line tangent to g of x equals square root of x at a equals 4. So let's work that out. We'll get the slope of this line by evaluating the derivative. So let's see, we've got g prime of 4 is equal to, I'm just plugging into this up here. I'm plugging into this up here, replacing the a's with 4's and the f's with the square root function. So we've got the limit as h goes to 0 of f of a plus h. In this case, g of a plus h. So g of a plus h, that's g of 4 plus h, which is the square root of 4 plus h. Then we've got minus f of a, so that's minus the square root of 4. And then on the bottom, we've just got h. Now, every time you set up a derivative, the limit that you get is going to be 0 over 0. You can see that here by plugging in the 0. You get square root of 4 minus square root of 4, which gives you 0, divided by h, which is 0. So we've got to do something. First thing I'm going to do is I'm going to rewrite this as 4 plus h minus 2 over h. And to get rid of this, what we need to do here is rationalize this thing. I'm going to multiply the top and bottom by square root of 4 plus h plus 2. That way, when I multiply this out, I get the limit as h goes to 0. All right. Let's see. When I multiply the two square roots times each other, the square roots cancel out and I'm left with 4 plus h. When I multiply these two together, it gives me plus 2 root 4 plus h, and this gives me minus 2 root 4 plus h. So those cancel, and then I'm just left with negative 2 times positive 2 gives me negative 4. Now on bottom, I'm not going to multiply it out. I'm just going to write it as the product h times square root of 4 plus h plus 2. Reason being, up here, the 4's cancel. And so I'm left with, don't have much room. I got enough. I'm left with the limit as h goes to 0 of, on top I've got h, on bottom I've got h times square root of 4 plus h plus 2. And I can cancel these and it leaves me with a 1 on top. So now I can plug my 0 in and I get 1 over square root of 4 plus 0 plus 2. So I wind up with 1/4. So 1/4 is That's f prime of 4. Now that's almost my answer, because the question actually said to find the equation of the line, and what we found here is the slope, so we're not quite done. I am out of room though. All right, tell you what I'm going to do. I'm going to finish this up here. The slope we found is that derivative 1/4, and the point on the graph, AF of A, is 4, 2. So I realize I'm cramming this in. Let's do this. So y minus 2 is 1/4 times x minus 4. So we get y is 1/4 x plus 1. My phone's ringing. Sorry about that. All right, so let's look at this on Desmos. Now on Desmos, I have square root of x let's see, let me zoom back in so we can see it. And we were talking about at the point 4, 2. So we're supposed to have the tangent line there. And the equation we came up with was y equals 1/4 x plus 1. And sure enough, that's the tangent line. We zoom in, we can see it's just barely sitting on the graph there. So that's good. All right. This next example, find the equation of the line tangent to this thing at a equals 5. Let's do that one. Again, f prime of 5 is the limit. Let me make my marker a little bigger. Is the limit as h goes to 0 of 1 over, let's see, this is supposed to be f of x plus f of a plus h. So this is, tell you what, let's do. That's f of x. F of a is f of 5, which is 1 over 5 plus 2, which is 1/7. F of a plus h is f of 5 plus h. If I put 5 plus h in place of x, I get 7 plus h. So I can take that and plug it all into my formula. F prime of 5 is the limit as h goes to 0 of f of a plus h minus f of a over h. So that's our derivative, and sure enough, you plug in 0 there. Up top, you're going to get 0, and on the bottom, you've got h is 0. So let's make this nicer. What I'm going to do is slide this down a little bit so that I can do it all up here. I'm going to multiply this by 7 over 7. I'm going to multiply this by 7 plus h over 7 plus h. And so what I get is limit as h goes to 0. Got this big compound fraction here. This first one's going to be 7 over 7 times 7 plus h. The next one is minus 7 plus h over 7 times 7 plus h. On the bottom, I've got just h. All right, so up top, h goes to 0. Wait a second, up top, I've got that. I've got 7 minus 7 plus h, so 7 minus 7 cancels. I'm left with minus h. And all of this stuff is divided by h, but instead of writing it out like that, I'm going to just multiply by 1 over h. That's equivalent. It looks a little nicer. And now I can cancel these guys. And I'm left with limit as h goes to 0 of negative 1 over 7 times 7 plus h. Now I can plug my 7 in without getting 0 over 0. I get negative 1 on top, and on bottom I get 7 times 7, which is 49. So that's my slope. I can call it m, or I can call it f prime of 5. All right, let's do the let's find the equation of the line and then graph it to see that this is what we get. The point that we have, x, y, or x1, y1, is 5. And the y coordinate that goes with that is 1/7. So what I get here is y minus 1/7 is equal to negative 1 over 49 times x minus 5. So I get y minus 1/7 equals minus 1 over 49x plus 5 over 49. So we got minus 1 over 49x. Now you could put this into a calculator if you wanted to. Adding 1/7 onto both sides, 1/7 is 7/49, so this will give me 12 over 49. So that is my line that's tangent to this curve. Let's check that up on Desmos. So on Desmos, my function is g of x, or no, it's f of x, not that it really matters, is 1 over x plus 2. And we're interested in the point 5. Let's see, 5 comma 1/7. Let's see, yeah, right there. Yeah, so this is a graph that looks like that. First, just sort of a sanity check. If you look at that, the slope at that point there at 5, the slope is really shallow, so it makes good sense that the slope is going to be something small. Negative 1 over 49. Also, it's going downhill at that point, so it makes sense that it's negative. Let's write our function in there. Y equals negative 1 over 49x plus 12 over 49. And it looks like it goes right through there. Let's zoom in on it and see. Whoop, zoom in. Yep, right there. We've got both curves there. If we zoom way the heck in, well, first let's zoom out. It looks like over here on the left side, the line is below the curve. On the right side, the line is above the curve. Wait, no, that's not right. It's below the curve everywhere. The red line is below the curve. But if we zoom way in, well, if you zoom way in, you can't really see it. But anyway, that's the tangent line.